11.7, mixed expressions and complex fractions. So we're going to take our rational expressions one step further, and our objective is to simplify not only the mixed expressions but also complex fractions. A mixed expression is very similar to a mixed number that you would think of in arithmetic. So basically there is a whole part and there is a fractional part. So that's what's going on there with example A. This one really isn't so bad. It has a plain number 3 plus 7 over x minus 2. Well, the good part about that is you don't have to wonder what the common denominator is going to be. So you have to have a common denominator, but it will definitely be what is there on the second part, the x minus 2. So the good thing is the 3 is really over what number? 1. So that's good. To make it have the denominator of x minus 2, basically what's going on there is you're going to multiply the top and bottom times x minus 2. Okay, so by doing that, I'm going to have 3x minus 6, because you distribute. The denominator is x minus 2, no surprise there. And then you just write the second part, that fractional part, you just repeat that. They now have a common denominator, so you go ahead and write that common denominator. And then you combine the numerators. So there's no x term on the right, so it would just be 3x. And you combine negative 6 and positive 7 plus 1. Just like everything else, you check and see if anything factors in any way for any kind of canceling. That one does not, so we've got our answer. So those are not bad at all. Those are not bad at all, mainly because that first part's going to be over 1. Okay, then you have to make sure it has the denominator, bless you, of the one on the right. Okay, any questions about what we just did there? Okay. So far so good. The second part actually is not awful. It's called a complex fraction, and what's going on there is it's a fraction in a fraction. So here's the thing about that. This, just like if it were just plain numbers, that bar means what operation? It means division. So let's think about this. This is really saying this problem. A to the 5th b over c squared divided by ab to the 4th over c to the 4th. And just like with fractions, we do not really divide, do we? We change division to multiplication, so let me work on that. A to the 5th b over c squared. The first fraction or rational expression stays exactly the same. You change division to multiplication, and then what do you do with the second fraction? Flip it over. So I'm going to flip it over. C to the 4th over a b to the 4th. And we have already done this before. You're looking for common things that factor out. So these just have variables that are going to cancel out. So I would go in alphabetical order. So with A's, there's 5 on top and 1 on the bottom. How many can cancel? 1. So the bottom one is gone completely. And the top, the 5 now becomes a 4. And then you go to the B's. There's 1 B on top and 4 on the bottom. How many are going to cancel? 1. So the 1 on top is gone completely, and the bottom, the 4, becomes a 3. In the C's, there's 4 on top and 2 on the bottom. How many are going to cancel? 2. So the ones on the bottom are gone completely, and the one on top the 4 becomes a 2. After you cancel everything you possibly can, you're going to have to muddle through the mess of things being marked out. But I would write on this a to the 4th, c to the 2nd, over b to the 3rd, and I would be done. So those are not too terribly awful. Now the only time those you have to do a little bit more is if the complex fractions would actually be like binomials or something like that, or trinomials that would need to be factored. But we did that back in chapter 8, back in 8, where you divided them out. Oh, you know what? No, it's been so long ago, but it was the beginning of chapter 11. It wasn't chapter 8, where we actually divided them and they were binomials or trinomials, and you factored them first and canceled everything out. So that could happen. Okay. All right. Questions about that? All right. That went really well. Let's look at the last one. This is now called a mixed expression. So it's a mixed expression in a complex fraction. So it's a combination of the two things we just did on top. So here's what's going to happen. You have to simplify whatever happens to be in that numerator to make it just a regular complex fraction, or just a regular fraction, sorry. Do the same thing in the denominator if needed. And then take the problem, break it apart into a division problem like we just did. The numerator divided by the denominator, and then multiply by reciprocal. So here, let's take it apart a little bit. I'm going to work on the top, okay? So if I work on the top, b plus 2 over b plus 3. Well, that b, remember, is over what? 1. And what common denominator am I going to have for the numerator? B plus 3. So I'm going to go ahead for just a second and try to organize myself. I'm going to put a b plus 3 with an empty numerator plus a b plus 3, and that numerator is definitely going to be a 2. Everybody with me? Over here on the top left, I need to take the top and bottom and multiply by what? B plus 3. And what that does for me is the top, I have to distribute that b and make it b squared plus 3b. Okay, now the denominator I'm going to leave alone for right now. It's not too messy, and put it over b minus 4. Okay, I still have not simplified that entire numerator yet, so let's go like this. I know I can combine them now because I have a common denominator, and when I do that I get b squared plus 3b plus 2. My denominator is b minus 4. Is there anybody that's not sure of where I've gone to so far? Okay, so here's my next thing I'm going to do. I'm now going to take this apart and use that division bar. So here's what it would look like. And I'm going to leave some space above this because I think my top over here can factor. I'm going to write b squared plus 3b plus 2 over b plus 3 divided by b minus 4. By the way, b minus 4, what's it over? A 1. Okay, so a couple of things got to happen here. I got to see if this factors or not. So I'm going to write 2 sets of parentheses right above it. That's why I left some space there. What would give me the b squared? B and b. The plus sign in front of the 2 means what, Jared? Same signs, and they're both going to be plus because of that. So plus and plus. So a factor pair of 2 that adds up to 3. Oh, yep, we're in luck. 2 and 1, right? So that one I'm going to mark out as no longer there, really. Okay, so there we go. Now I need to take care of the division. Nothing else factors. Now, if you had other parts that factored, you would do that at this time. You'd factor whatever you could. Now I'm going to do this. Next step. B plus 2, B plus 1 over B plus 3 times 1 over B minus 4. Does anything cancel? Sure doesn't, does it? If it did, this is when you would cancel it out. And you come over here and my answer is going to be B plus 2 times B plus 1, B plus 3, and B minus 4. And you do not have to multiply that back together. You'd be better off leaving it just like that. Simplify your life a little bit. Don't try to get fancy. Just leave it. If anything cancels, definitely cancel it. Otherwise, that mess kind of is your simplified answer. But it does look a little bit better than that. So there you go. Questions about that? That is taking a mixed expression and simplifying it out of a complex fraction. So we've taken both parts above and simplified it. Questions?